Hello, seniors. We're going to continue with electronic assignment number 9, which is about the chain rule. We have already seen this example together where we introduced the concept of the chain rule. So we're going to go now to more exercises and the definition of the chain rule. It says, to find the derivative of a composite function, we use chain rule. Okay, so whenever we see a composite function, we need to apply chain rule. It says the chain rule. If f of x is u of v of x, then f prime of x is the derivative of u but remaining with the function, the original function v, times the derivative of the inner function, which is the derivative of v. Okay. Then it says the chain rule can also be written as y equals fu. But u is another function, so u is equal to g of x. So y is the composite function f of g of x. So then the derivative of y with respect to x is the derivative of the function with respect to the inner function, that's the u, times the derivative of the inner function. Okay, this seems to be a little bit complicated, but you'll see that it's quite easy. And this is exactly the way it is presented in the formula booklet, okay? So you should understand that this is referring to the chain rule when you see it in the formula booklet. Okay, here you have in words what you have to do when you apply the chain rule. It says, the derivative of a composite function is the derivative of the outside function with respect to the inside function. And in parentheses it says, the inside function remains the same, comma, multiplied by the derivative of the inside function with respect to x. Okay, if you understand this correctly, then you see that the chain rule is not that difficult. Okay, so let's see some examples. For part A, it says each function is in the form f of x equals u of v of x. So they are all composite functions. Identify u of x and v of x, and then find the derivative of f. So, in the first case, part A, f of x equals 4 times 5x cubed plus 2 to the 6th power, okay? So, if we were to identify u of x, the outside function, in this case, would be 4x to the power of 6, right? We consider this to be x, okay? As I told you, identifying the outside, the outside function is practice, right? There's no rule of thumb or nothing, it's just practice, okay? And v of x, the inside function, in this case, would be whatever we have inside the parentheses. 5x cubed plus 2 in this case. Okay, so I'm just going to find the derivative of each of these functions. So the derivative of u, in this case, is 24x to the 5th power, right? To the 5th power. And the derivative of v prime of x, in this case, is 15x squared plus 0, right? We don't need to write the plus 0. Okay, so if we want to find the derivative of f prime of x, basically what we need to do is, let me see, this over here. It's the derivative of u with the inner function remaining the same times the derivative of v. Okay, so the derivative of u is this. Okay, so I'm going to write 24. Instead of writing x, I need to write the original v function, right? The original v function is 5x cubed plus 2. So that's exactly what I'm going to do. 24, but instead of writing x, I write 5x cubed plus 2. And then we multiply this by the derivative of the inner function, which is 15x squared. So times 15x squared. So let me write this using the same color notation just to show you. What I did here is exactly what is highlighted in green over here. So I'm going to write this. It's the derivative of the outside function, with respect to the inside function. And this means that the inside function remains the same. Okay, so that's exactly what we did in the green part marked there. And for the orange part, which is this part over here, it says multiplied by the derivative of the inside function with respect to x. So what I just marked in orange is the derivative of the inside function with respect to x. Okay, that's exactly what we do when we apply chain rule. Okay, so this is not the final result because we can simplify this a little bit, right? We can multiply 15 times 24, for example. So the final answer would be 24 times 15, that's 360. So this is, just a second. So this is equal to 360 x squared times, sorry, I just noticed I forgot something here. It should be to the fifth power, there you go. Times 5x cubed plus 2 to the fifth power. And that would be the final result. So we highlight this, or we mark this, we frame this, and this is the answer for the first exercise. Okay, this, you will see that with practice this becomes much more mechanical, and you don't need to write all of this process in order to do a chain rule. You can just do this mentally, but because these are the first exercises, I wanted to do them showing all the steps, right? Okay, so for part B, same thing. We're going to identify the outside function, which in this case, the outside function u of x would be the square root function, right? Square root of x. And the inner function would be whatever we have inside the square root, right? Which in this case is 4x squared plus 1. Okay, once we have identified both functions, we can find the derivative of both. Remember that, okay, u of x, we can rewrite this as x to the power of 1/2 in order to do the power rule. So the derivative u prime of x using power rule would be 1/2, we take the 1/2 in front, times x to the power of 1/2 minus 1, which is negative 1/2. Okay, that's the derivative. And for v of x, let me do this, I'm going to see if I can make it fit here. V prime of x, in this case, would be 8x plus 0, so we don't need to write that down. Okay, once we have done this, we can find the derivative of function f, right? It's the derivative of the outside function with respect to the inside function, where the inside function remains the same. So I'm going to write the derivative of u, which is 1/2. Instead of x, I need to write whatever the function v is, right? So times 4x squared plus 1, this is being to the power of negative 1/2, to the power of negative 1/2. And we need to multiply this by the derivative of the inside function with respect to x. That is 8x in this case. So times 8x. So once again, I'm going to mark these two parts. Let's see if I can grab all of this. There, duplicate, and take it here. And that's it, correct. Okay, so once we have done this, if we can simplify these terms, we simplify. For example, I see that the 2 simplifies with the 8, we get a 4 here. So the final answer would be f prime of x equals this is to the power of negative 1/2, so I can write this as 4x on top divided by, I'm going to take this a little bit more to the top, 4x divided by the square root of 4x squared plus 1. This would be the derivative of function f in this case. There you go. So I hope this is being clear for you. Let's do another exercise. Part C says the following: f of x is equal to e to the power of x squared. E to the power of x squared. Okay, so once again, here we can identify a function inside another function, right? We can say that ux, in this case, the outside function would be e to the power of x, and v of x, the inner function, can be the exponent itself, right? Which is x squared. X squared is the inner function. One way of checking this is by finding fog, right? In this case, u of v of x. If you do this, u of v of x, we need to plug in function v into function u, and you will get e to the power of x squared, which is exactly what we have over here. Okay, so that's one way of checking if you're doing the right thing when doing the composite function. Okay, so the derivative of u, the derivative of e to the power of x is e to the power of x. So that we leave that as it is. And the derivative of v prime of x, is 2x. Okay, so once we have done this, we perform the chain rule. F prime of x is equal to the derivative of the first function, that is e to the power of x, but instead of writing x, we write whatever the function v is. So this is e to the power of x squared times the derivative of the inner function, right? Which in this case is 2x. So that's the result, right? We can simplify this, and we can say that, let me see if I can bring this text again, just to make it clear. Duplicate and see if it fits. Yes. Okay, but I need to change here the green and yellow. So this would be the first part, and this is the second part. Okay, so the final answer would be f prime of x equals 2x times e to the power of x squared. Generally, the x itself is written first, and then any other function such as e or natural logarithm or whatever. So that'll be the final result. Okay, so I hope this is being clear for you. Let me just show with an arrow this. There. Okay, let's see another example. It says, use a chain rule to find the derivative of that function, f of x equals 1 over x squared plus 1. Okay, instead of doing a chain rule, we could also do the quotient rule, right? That's another way of solving this. But since we're asked to specifically solve this using the chain rule, that's what we're gonna do. Okay, so we need to be able to identify, as we want to solve the using chain rule, we need to be able to identify the two functions that together compose the function f, right? So I can say that, for example, u of x, the outside function, is equal to 1 over x, right? A rational function, like this. And then v of x, is equal to whatever we have down here, right? X squared plus 1. So you see that if I compose these two functions, then I'll get function f. Okay. I'll take this here. There. No, I don't like it. There. Okay. So if I find the derivative of both, we're going to say that u prime of x, or first of all, I can rewrite u of x in this case as x to the power of -1, right? If I want to solve this using the power rule. There. So then u prime of x would be equal to -1 times x to the power of -2, right? -1 minus 1, that's -2. So that's the derivative of u of x. And then for the derivative of v, we're going to find v prime of x, and this is equal to 2x plus 0, right? So 2x is the derivative of function v. Finally, we're going to find the chain rule, well, derivative of f by applying chain rule. So we do the derivative of u, but instead of x, we're going to write function v, right? That's what the chain rule states. So I'm going to do minus 1 times x. Instead of x, I'm going to write x squared plus 1. This is being to the power of -2 times the derivative of the inner function, which in this case is 2x times 2x. 2x. And that's it. I can reorganize this in order to write it in a more fashion way. So I'm going to bring the text back again just to make sure that this is clear. Let's see. Here. There you go. So this fits perfectly. So the final result will be f prime of x is equal to, and I just need to reorganize this, -2x. And since this is to the power of -2, I can take it down to the denominator and write it as x squared plus 1 squared. And that would be the result for this derivative. Okay? Super. Let's move on to the next set of exercises. I think this is the last. Yes. So let's see these 3 exercises. It says, for some functions, the chain rule must be combined with the product or quotient rule, or the chain rule may need to be repeated. Okay, so these are a little bit more complex derivatives, but because we need to combine different concepts or different ways of finding derivatives, according to the rules we have studied. Okay, so let's see. For part A, for example, we have f of x is equal to x times the square root of 1 minus x squared. Okay, the problem here is that if we were to have only this function, this would have to be solved by applying chain rule, right? But besides that function, we have this function x, which is being multiplied to the square root function, right? So to solve this one, I will have to apply chain rule, but then to solve all of this, I will need to apply product rule, okay? So it becomes a little bit more long in this case, but the process is exactly the same. So let's see. We can say that, well, we know that we need to apply product rule because there's a product here between the two functions, x times 1 minus x squared. So what I will do is I will find, or first of all, we're going to remember how the product rule works. The product rule states the following. If we have, let me do that here. If we have a function u times a function v, then the derivative of this function, so if, let me write this, if f of x is equal to u of x times v of x, there you go, then the derivative of f prime of x would be u of x times v prime of x plus v of x times u prime of x. This is what the product rule states. Okay, so just to remember that. This one a little bit messy. Never mind. There you go. Okay, so First of all, I see that we have that function u of x in this case is equal to x, right? So if we find u prime of x, this would be equal to 1, right? The derivative of x is 1. And the function v is the square root function, right? The square root of 1 minus x squared. But again, in order to be able to solve this, I would need to apply the chain rule, right? So I can define, I'm going to define two functions here. Let's say, for example, r of x, which is the square root of x, the square root function, and s of x would be, let's say, the inner part, which is 1 minus x squared, okay? So by solving this, we can find that r prime of x, the derivative of the square root function, we already found that here. Where is it? Here. This is the derivative of the square root function. So I'm going to write this. So this is equal to 1/2 times x to the power of negative 1/2. Okay? And the derivative of s, I'm going to do it down here. S prime of x, in this case, is equal to negative 2x. Negative 2x. Okay, so now to be able to find the derivative of function v, which is what I want in order to apply the product rule, I need the derivative of v. So v prime of x would be equal to the outside function, the derivative of the outside function, that's 1/2. Instead of writing x, I'm going to write 1 minus x squared, which is function s, right? This is to the power of negative 1/2. And this is being multiplied by the derivative of s, which is negative 2x. I see that I can simplify some terms. For example, the 2 simplifies with this 2. And that's it. So v prime of x is equal to a negative x over, because I have a negative exponent here, over the square root of 1 minus x squared. The square root of 1 minus x squared. Okay, there's nothing else I can do here, so this would be the derivative of function v. Okay, this is still not over, because now I need to apply the product rule, right? In order to be able to find f prime of x, which is what I wanted to find from the beginning, I need to apply the product rule. So it says function u, which is x, times the derivative of v, which is what we just found here, so times all of this, which is negative x over 1 minus x squared, square root of all of that, plus v, function v original, which is square root of 1 minus x squared, 1 minus x squared, square root, times u prime of x, which is 1, times 1. Okay? Finally, if I simplify all of this, I will get my final result. So let me simplify this. We would get that f prime of x is equal to negative x squared over negative x squared over the square root of 1 minus x squared plus the square root of 1 minus x squared. Okay? I can, if I want, simplify this a little bit more. I'm going to write the final answer by simplifying this, but if you stay with this, this will be fine. The final answer, the most simplified version, would actually be f prime of x equals 1 minus 2x squared over the square root of 1 minus x squared. And that is obtained by doing a rationalization, right? If I do a common denominator of 1 minus x squared square root, and then I simplify terms, I'm going to get this as my final answer. But if you get up to here, that's fine. Okay, let's move on to the next exercise. In this case, it says f of x is e to the power of 2 times 3x minus 1 to the 4th power again. In this case, we would have to apply the chain rule multiple times. In this case, we have 3 composite functions. Let's see. If I define the outside function as e to the power of x. That'll be my u of x. I'm going to find the derivative already. U prime of x would be e to the power of x, right? Then we have the second innermost function, which is v of x. That would be 2x to the fourth power, right? 2x to the fourth power. So then the derivative of v is 8x cubed. 8x cubed. And finally, the innermost function, I'm going to call this r of x. The innermost is this one over here, 3x minus 1. 3x minus 1. So the derivative of r is equal to 3. Okay? So now that we have found all of the different functions that compose the function f and their respective derivatives, I'm going to apply the chain rule. So f prime of x, and pay attention here because this will prove if you really understand the concept, is the derivative of the first function remaining with all of the x's, whatever we have as x, the same as the original, right? So e to the power of, instead of writing x, we're going to write all of this, right? All of that we can see there. So this is, let me write that as, I'm going to do it like this. I'm going to mark this. All of this is the x we need to write here. So this is e to the power of 2 times 3x minus 1 to the fourth power, okay, times the derivative, the second derivative, but instead of writing the x, we're going to write whatever the original function r is, okay, so this would be our x in this case. So this is times 8, and instead of x cubed, I'm going to write 3x minus 1 cubed. And finally, times the derivative of the innermost function, which is 3. Okay? I hope this is clear for you guys. So once I have done this, I just need to simplify terms. I see that I can multiply 8 times 3, that's 24. 24 times 3x minus 1 cubed times e to the power of 2 times 3x minus 1 to the fourth power. So this would be the derivative. This would be the derivative of this function f. I'll write that here. There you go. Finally, we have one last exercise, which says f of x equals natural logarithm of x over x squared plus 1. Okay, in this case, once again, this is similar to the first one we did. We have both things. We have here inside, we have quotient rule, and then we have a natural logarithm of all of that, right? So we will have to apply chain rule and quotient rule at the same time. Okay, so just to remember, the quotient rule says that if f of x is a function u divided by a function v, then the derivative of f is equal to vx times u prime of x minus ux times v prime of x. V prime of x, oh, I cannot make it fit. There you go. Times v prime of x divided by v squared. Vx, and all of this squared. Okay, this is what the quotient rule is about. Okay, so first thing, we're gonna apply the quotient rule in order to solve the derivative of whatever we have inside there. So I'm gonna say that u of x, well, I'm gonna define u of x as the outsidemost function. This is natural logarithm of x, right? So the derivative of u prime of x, derivative of natural logarithm is 1 over x. Okay, and then we have v of x, which is the quotient function or the rational function. So v of x is equal to whatever we have inside, but I'm gonna define v of x as x already, just to apply chain rule directly. So v prime of x is equal to 1, right? And let's say r of x is x squared plus 1. Oh, x squared plus 1. So r prime of x would be, in this case, 2x. Okay? So now I will apply the quotient rule. The quotient rule says that, and I'm only applying this for these two functions, so for v of x and for r of x. So let's call the derivative g prime of x, just to give it a name. So this is equal to v of x times u prime of x, that's r of x, which is x squared plus 1. This is being multiplied by v prime of x, which is 1, minus u of x, which in this case is x, times r prime of x, which is 2x, times 2x. And this is being divided by v of x squared, so it's r of x squared. X squared plus 1 squared. Okay, then we need to simplify this. If we simplify this, we're gonna get x squared plus 1 minus 2x squared divided by x squared plus 1 squared. So if we simplify terms, it's 1 minus x squared divided by x squared plus 1 squared. Okay, so that is the result of the quotient rule. Now I need to apply the chain rule. So I'm going to write chain rule. So for the chain rule, the derivative of f prime of x, would be the derivative of this function remain with the x changing to this, right? To whatever I have inside there. I'm going to mark this. I use green. All of this would be what I'm going to write as the x here. There. So this is 1 over all of that, which is x over x squared plus 1. And this is multiplied by the inner derivative, which is what we just found, right? 1 minus x squared over x squared plus 1 and all of this squared. Okay, so then I need to simplify this. If I simplify this, I can take this up here, right? So this would be x squared plus 1 over x times 1 minus x squared over x squared plus 1 squared. So I see that I can simplify this exponent with all of this, and that would be it. Yes. So f prime of x is equal to 1 minus x squared over x squared plus 1. And that is the final answer. We did some tricky exercises, people, so you're going to be practicing with lots of exercises about this, so don't worry much if you're not understanding this clearly. Once you practice and you do this on your own, you will see that it's not that difficult. Okay, so I hope this was clear enough for you. If not, please let me know, and see you next time.